All right, this is the exponential function, okay? So I know it's not log because 1, it doesn't say log, but 2, you've got a base that's a number being raised to an exponent. That's exponential, which means you plug in for the x, and it means there's a horizontal asymptote. The horizontal asymptote is determined by the vertical shift, and a vertical shift looks like this. So this is a shift down 4, which is why my horizontal asymptote shifts down 4, okay? And why the equation there would be, what this should be y. Y equals x, or sorry, y equals -4. That would be your horizontal asymptote. You have to graph your horizontal asymptote. So a lot of you didn't, I like drew it on your slide for you, but you have to have your horizontal asymptote. Because if you don't, it doesn't take on that curve. That curve has to happen. It can't cross through where the horizontal asymptote should be. So just be really careful there, okay?
+4 for the range?
No, the range is -4 because it starts at the horizontal asymptote and then it goes up. Your domain is all real numbers for exponential. And then the range is that lowest point, which would be where the horizontal asymptote is, up to +infinity with a parentheses on both. And then when you plug in your points, you should have got -3, -2, and 0. 0, -2 is your y-intercept. It has to be in coordinate point form. So a couple of things that you would have lost points on is if you didn't get it y equals for your asymptote, it has to be an equation, okay? If you didn't draw the horizontal asymptote, that has to be part of your graph. Just make sure you have all that stuff. Overall, it was pretty good, but there's a couple things like nitpicking things here or there that will cost you points. So don't do them. I know there's a different approach to this one because it's got the log. It's got the word log in there, right? And logs we approach differently. Logs, we plug in for y. First of all, that's a big deal. 2, we have to put in exponential. So when you are looking at your exponential, you're looking for a vertical shift to affect your asymptote. With a log, you're looking at the horizontal shift to affect your asymptote. The horizontal asymptote shifts based on what happens inside those parentheses. So because x plus 2 is inside the parentheses, if I set this equal to 0, I'd end up with x equals -2, and that's your vertical asymptote. So now I have a vertical asymptote at x equals -2. It has to have the x equals to not lose points, okay? And then you have to plot it. Then from there, I want to put this in exponential. Before I can have this 2 pick up the y, which is there, you have to isolate it. So that +3 has to move to the other side. So I would get y equals log base 2 of x plus 2 plus 3. I'd subtract the 3. Y minus 3 equals log base 2 of x plus 2. And now the 2 picks up the y minus 3. So my exponent is y minus 3 equals, this drops off x plus 2. And then I subtract that 2. And I get 2 to the y minus 3 minus 2 equals x. And that's what I'm plugging in to the y. Because it's a log, again, we plug into the y. So one at a time, I'll plug those in. I'd get 2 to the -1 minus 3 minus 2. 2 to the 0 minus 3 minus 2. And 2 to the 1 minus 3 minus 2. So -1 minus 3, this is 2 to the -4th minus 2. And 2 to the -4th is 1/16. Minus 2 is -1 and 15/16. Then I get 2 to the -3 minus 2. That's 1/8 minus 2, or -1 and 7/8. And then I get 2 to the -1 minus 3. Sorry, so 2 to the -2 minus 2 is 1/4 minus 2. -1 and 3/4. And then those are the corresponding y's. So -1 and 15/16, -1 and 7/8, and -1 and 3/4. Then you go to the graph and you plot these coordinate points. Be careful and make sure you don't switch up your x's and your y's. The x is -1 and 15/16 and -1. So -1, 15/16 is really close to my asymptote, down 1. A little bit further from that asymptote, I'm at 0. A little bit further from that asymptote, I'm at 1. So that curve doesn't really take a hold. If I wanted to see the curve, I could plug in some more points. Like I could keep going on that y. Or I just know because it's a log, it has that like arc shape to it. and I can complete my graph. It has to have that shape. Your domain is restricted for logs, and it's based on that horizontal or that vertical asymptote. So if my asymptote is at -2, that's where my domain starts. It goes from -2 to positive infinity. The range is all real numbers for logs, just like it would have been the domain for your for your exponential functions. And then we already found the vertical asymptote is x equals -2, and your x-intercept comes from plugging 0 in for y, so -1 and 7/8 and 0. Some of you did great on it, and some of you have a lot of work to do to practice these graphs. There are practice ones on the quiz review. You need to do them. It should be on your to-do list now. So this is the quiz review. This, again, first whole slide, and there's obviously a couple of the graphs for exponential, and then there's a couple graphs for logs. You're only getting one of each one on the quiz. There's no calculator whatsoever, so don't use it because you're going to get a false sense of security. When you get down to, this is all 5-1. This was your one-to-one property, so changing of the base. The good thing is we've been practicing these. And then you get into the ln's. Well, this is all still just log functions. For these, the wording on this says to evaluate the log at the given value of x without using your calculator. So for 16, for example, if it says log base 2 of x and then x is 64, this goes into the x. So I'm finding log base 2 of 64. Don't let the verbiage on or the wording on it throw you off. Okay, then you actually would evaluate that. And you're going to do that for each of these. Okay, on the second page, the top is your one-to-one logs, which we practiced yesterday, okay, because it was in that section too. Then comes the graph of your exponential. Then all your ln of e's. These are without a calculator, so these should all simplify using all the shortcuts for ln's. 5.3 is rewriting it in terms of a common log or natural log. It said round your answers to 3 decimal places, but you're not going to have your calculator on your test, so you're not going to do that part. You're just going to set up your ln over ln or log over log. And then it continues on the end. Again, now we're in this one, you're expanding. So remember, if you're expanding, if it is multiplication, it becomes addition. If it's division, it becomes subtraction. And if you have a number on the front, or an exponent, moves to the front. And then the reverse is true for, now we're condensing. With the condensing, addition goes to multiplication. Subtraction goes to division. And number on the front goes to the exponent. So you're going to expand and condense. And again, there's lots of examples here. There's 14 questions on your quiz, but it could be any of those. So you want to just make sure that you're prepared for all of it. These shouldn't take too long. Hopefully these are your time savers because obviously the graphs take longer. Tomorrow is early release, so you are a shortened class period, which means you get to class, you get yourselves together so we can start as soon as you get here. Okay? Yeah.